Hi everyone, welcome to Chemistry Portal. I am Sudhanshu Kumar and today we will discuss how to compare the energy of orbitals. Right. So first thing we will discuss for single electron species like how to compare the energy of orbitals for single electron species, and then we will talk about for multi electron species, right? So we will do one by one, right? So first of all, for single electron species like hydrogen, He plus or Li plus 2, etc. In that case, means if you have some atom or some a species having only one electron, that is called single electron species, right? And in such case, energy of an orbital depends on value of n, right? This n means what? This n means principal quantum number. Principal quantum number, right or not? Principal quantum number. Okay, this is very very important. So for the single electron species, energy of an orbital depends only on value of n, right? Clear everyone? Okay, now suppose if I give you example here, suppose if I have to compare the energy of 3s, 3p and 3d orbital, then how to do that? So first of all, check the value of n, right or not? See, before going to this, I want to tell you just notation, okay? What does this 3s mean? What does this 3p mean, right? So this letter before the alphabet, this means principal quantum number. It means this orbital present in which cell, in which energy level. Okay, that is called here. That's what this number indicates, right? So this 3 is your principal quantum number. It means it's a cell number, and cell number is nothing but it is energy level of electron, right? So this 3s means what? This 3s means this s is your orbital, right? This p is your orbital and this d is your orbital. Okay, but this 3s means this orbital is present in the third cell, right? That's the meaning of this 3s and 3p and 3d and so on. Okay, suppose here you have, here this is the atom, we have here nucleus, and here I take in a third cell, that is the third energy level, n equal to 3. So 3s means in this cell n equal to 3, the s orbital present in the third cell, right? And that is called 3s. 3p means in the third cell you have p orbital, that is called 3p. 3d means in the third cell you have d orbital, that is called 3d. So this is the meaning of 3 and here here alphabet, right? So this alphabet represent the orbital and here this letter represent the principal quantum number. So in this case, for single electron species, you just have to check value of n here. So in this case, you have all the orbitals having the same value of n. 3 here also, here also 3. It means all these are having a same energy, equal energy, right? So it means conclusion is what? Conclusion is 3s equal to 3p equal to 3d. All are having a equal energy because all are having a same value of n, right? Okay. Now suppose if I take here example of 4s, 4p and 4d and 4f, then now compare the energy of orbital for this single electron species. Then see here, in this case also we have all the orbitals having a same value of n, 4, 4, 4. Here also it means all these orbitals having a equal energy, but this is valid when? This is valid only for single electron species. This is very very important. But suppose if I ask you compare the 3D and 4s for single electron species, in that case 4s will be having a higher energy, right or not? Okay, n value more, it means energy also more. Understood? Energy also more. Clear everyone? Right? Suppose if I ask you compare the orbital energy of 3D and 4s for single electron species. So first of all check the n value. Here it is 3, here it is 4. In that case 4s will be having a higher energy than 3D. But in the third cell, all the orbitals having a equal energy, right or not? In the third cell, for same quantum number, all the orbitals will have equal energy. Understood? Right. Now we will talk about for multi electron species, how to compare the energy of orbitals in multi electron species like helium, lithium, sodium, potassium, etc. Right. In that case, energy of orbital depends on both n and l value. Right. Energy of an orbital depends on both principal quantum number and azimuthal quantum number. We have already discussed all these things like principal quantum number, azimuthal quantum number, all these things are discussed. Okay, go to the previous lecture, right? And the link is given in the description box. You can check, right? Go through it. Okay, so now come to the point. For multi electron species you have to check what for the multi electron species energy of orbital depends on both principal quantum number and azimuthal quantum number. First of all, rule how to compare the energy of orbital for multi electron species. First of all, first rule, you have to check n plus l value, right? You have to check n plus l value. If n plus l value is more, it means that orbital having a more energy. Understood? Suppose for example 3s, 3p, 3d. And if I ask you compare the energy of orbital for multi-electron species for 3s, 3p, 3d, then your answer should be what? Your first task should be find the n plus l value, right? So for this one, n plus l value is how much? Here 3 is n value, right? So 3 plus 0, because we know that for s orbital we have l value 0, for p orbital we have l equal to 1, for d orbital l equal to 2, and for f orbital l equal to 3. This thing you have to remember by heart. Okay, understood? So similarly for 3p you have n plus l value, that is a 4, and here you got 3, and here for 3d you have n plus l value is how much? 3 plus 2, 5, right? So we know that if n plus l value is more, it means what? More energy of orbital. So in this case 3d having a more n plus l value, that's why 3d is highest. That's why 3d is having a more 3d having a more energy, then you have 3p, then you have 3s, right? 3 is having a lowest energy. Okay, but sometime what happen, you will find some questions in which n plus l value becomes same, coming same, then what to do? Then how to compare the energy of orbital? In that case you have to check the n value. In that case you have to check the principal quantum number value. If the value of n is more, it means energy also will be more, right? For suppose here for 3d and 4p, which is having a more energy. So first rule is what? Apply the rule order wise. Okay, don't apply rule number 2 first. Okay, always apply the rule number first. If rule number 1 is same, then go to rule number 2. Understood? Go in order wise, right? That's very important. Okay, now so here for 3d find the n plus l value and find for 4p also. So you will get here n plus L value will get here 3 plus 2, that is a 5, and here also 4 plus 1, that is a 5, right? So it means in this case 3D and 4p, you are getting a 5, 5, both are same, n plus L value. So now check the n value. If you have n value more, then energy will then energy will be also more, right? So in this case 3D having a n value, that is a 3, and for 4p n value is 4. So which is a bigger? 4, no? That's why 4p is having a more energy. That's why 4p orbital having a more energy, right? So that's how we can compare the energy of orbital for multi-electron species, right? Clear, everyone? See, recall. First thing, for single electron species, you have to check just a value of n, right? And for single electron species, energy of orbital depend only on n. N value more, energy more. N value same, energy will be same, like this. But this is valid for only for single electron species. Now for multi-electron, we have to check first of all n plus L value. If n plus L value more, then we are having a more energy of that orbital. And if you have n plus L value is same, then check the n value. If n value is more, then more energy of that orbital. Understood? Now let's take some question here. Compare the energy of orbitals and consider for multi-electron species. Okay, so we have some orbitals here: 2s, 3s, 3d, 4s, 4p, 4d, 4f. So first of all, apply the rule number 1. Right, because we are dealing with multi-electron species. See here. So first of all, find the n plus L value. So here for 2s you will get 2, for 3s you will get n plus L value 3, 5, 4, for 4p 5, for 4d 6, for 4f 7. See here. So it means 7. So n plus L value is highest for 4f. Right, so it means 4f having highest energy, more energy. 4f orbital has more energy. Then you have 4d, and then you have 3d and 4p. But how to compare the 3d and 4p? Because here also 5 and here also 5. Then how to compare the 3d and 4p? So now apply the rule number 2. If n plus L value is same, then we have n value more, energy will be more. So in this case 3d and 4p, you have here 4 is more, right, than 3. That's why 4p having a more energy. And then you have 3d, and then you have 4s, that is a 4 here, and then you have 3s, and then in the last you have 2s. And this is the increasing order of energies of these orbitals for multi-electron species, right? So this is all about energy of orbital, like how to compare the energy of orbital for the single electron species or multi-electron species. Okay, right? If you found this video helpful, please like, share and subscribe our channel, Chemistry Portal. And if you have any questions, you can ask me in the comment box. And thank you everyone. Thanks a lot.